This episode on military aviation history is sponsored by the Royal Air Force in collaboration with the Battle of Britain Memorial Flight. I'm standing in front of the Spitfire Mark 9, specifically an LF9. This plane was built in February 1944, so it has just had its 75th birthday. And it's a genuine D-Day veteran flying with the Canadian 433rd Squadron during the landings in Normandy, France. Nowadays she is kept in tip-top flying condition by the Battle of Britain Memorial Flight. And today we're going to have a look at the history of the Spitfire and at this magnificent aircraft. Hello everybody and welcome back to Military Aviation History. I'm your host Bismarck and I'm here to tell you all about the Spitfire, and then we'll have a look at the Mark 9. The Spitfire's history is somewhat different to many of its fighter contemporaries, as the company that built them, Supermarine, wasn't really known for the aircraft such as this one, but it had a background in float and seaplanes. Back in 1931, the Air Ministry released specifications F730, calling for a new fast monoplane fighter able to operate both day and night. Now, R.J. Mitchell of Supermarine Aviation Works tried his luck with an open cockpit fixed-gear gull-wing monoplane powered by the Rolls-Royce Goshawk. Although Supermarine was known for its float and seaplanes, the Schneider Trophies, a prestigious interwar racing event Supermarine had won twice with their S6, gave him plenty of experience and insight into designing a fast, high-performance aircraft. The design was known then as the Type 224 and it had several merits and some peculiarities like an added air brake. Initially the design was rated as the best in order of merit. However, the original specifications and all the submitted designs varied too much for any adoption at this point. The Supermarine design was the fastest yet remained underpowered as well, and it had a large fixed undercarriage, thick gull wings, a high landing speed, and the inclusion of an experimental evaporation cooling system made it prone to mechanical failures. As well as that, some bureaucratic shifts inside the Air Ministry meant that suddenly the interest in a plane based on the original specifications waned. Eventually, the lack of any suitable monoplanes, the Gloucester Gladiator was awarded that contract. The Type 224, although featuring advanced and forward-thinking design choices, ended up as a gunnery target on an army base. Undeterred by this, however, and somewhat wiser, Mitchell continued to tweak the design. He added a retractable landing gear, enclosed the cockpit, cleaned up the lines, and finned the wings into that trademark elliptical shape. But what would be a plane without its power plant? Supermarine turned once more to Rolls-Royce, who had just come out with a brand new inverted V12 engine. You might know it as the Merlin, and it was this engine that gave the plane just the wallop that was needed. This new design was armed with 4 303 Browning machine guns, with provisions for up to 8 small bombs under the wings, and it maintained some artifacts from the Type 224, like the evaporation cooling system. That was eventually ditched for the merit of Radiator. Supermarine took the initiative to forward the specifications to the Air Ministry itself, who then drew up F3734, more or less based verbatim on the presented specs. It later awarded a £10,000 contract to Supermarine for a prototype. This plane became known as the Type 300. Only a year later, the ministry released F1035 directly to Mitchell. Now, this set of specifications caused some bureaucratic back and forth, but again, that's a story for another time. Suffice it to say that the main difference was that the specifications were, well, more specific about performance, notably calling for an aircraft 40 miles per hour faster than any contemporary bomber, and that armament had to be increased from 4 to either 6 or 8 Browning 303s. Now, there was also a debate on whether the bombs were to be deleted at this point, and yes, eventually they were. As a side note, the company Hawker had a very similar plane in development at this point in time, the Hurricane. In March 1946 then, the prototype K5054 was ready. It took up for its 8-minute maiden flight at what is now Southampton Airport. Upon landing, the test pilot Captain Summers jumped out of the plane jubilant and is supposed to have said, "Don't touch anything." While this reaction might sound like quite the endorsement, the plane was far from ready. During its maiden flight, there had been very little time to actually test the aircraft, and Summers hadn't even raised the landing gear. After more flights and actual testing, Mitchell himself was rather disappointed, specifically in regards to the top speed. However, after some changes, eventually a speed of 349 miles an hour was achieved. That's 1 mile an hour slower than what he wanted, but he was a practical fellow, so he took what he got. Over the following months, as the plane saw incremental design changes, the test pilots would discover several issues: an oversensitive rudder, little initial performance difference to the Hawker Hurricane, as well as that, problems with ground clearance and the center of gravity. The latter two issues were never really overcome. As well as that, oil leaks were frequent and bad fittings caused unnecessary drag. The ailerons and the wings had also twisted and had to be modified. It's about this time as well that the air intake was completely redesigned. Nevertheless, after several changes to the aircraft, the Air Ministry ordered a first batch of 300 aircraft in mid-1936. It was also around about this time that the plane was officially christened Spitfire, as per a request by Supermarine. And yes, one other potential name proposed was Shrew, but that would have been a bit suboptimal. Anyway, ordering the Spitfire at this point might have been a little bit rash. The Spitfire itself, and Supermarine specifically, was far from being able to appease such a high production order. As a small company, mainly known for their flying boats, they did not really have the capacity to jump straight into production. At the same time, Supermarine wasn't exactly happy to subcontract the aircraft out to other companies. So after considerable delay, the production did get going in 1938, and the first Mark Is would be entering service with number 19 Squadron. In its construction, the Spitfire was not much different to the new breed of fighter aircraft coming out across the world. Powered by a powerful inline engine, it featured all the modern refinements of a retractable landing gear, an enclosed cockpit, as well as a low-drag, low-wing monoplane design. However, this did come at a price. Unlike earlier designs, the Spitfire was labor-intensive. The stressed duralumin skin fuselage supporting part of the structure was riveted down while folded over 20 different frames. The frames each unique, each further modified by lightning holes. The interior, especially around the power plant, very cramped. Now the wings, of course, here the trademark, are perhaps the most recognizable feature of the Spitfire. It gave them some of the most fantastic flying characteristics of its time, but again, labor intensive. 26 different sized ribs were set between the main and the rear spar. Trailing edge was twisted slightly across its length, and this gave the plane a very forgiving stall characteristic, but only when built exactly to specs, and early on that was not always the case. And the control surfaces themselves here featured a duralumin skeleton covered in canvas. In the end, the semi-elliptical shape was just thick enough to house the gear and the guns, although even there, some compromises had to be made by spacing the guns out instead of keeping them in a concentrated set. This did somewhat negatively affect the concentration of fire when compared, for example, to the Hurricane. The Spitfire we have here is, of course, the Mark LF9. LF stands for low flying, showing that this aircraft has been optimized for fly at lower altitudes, specifically with the Merlin 66. You're currently seeing the aircraft with the trademark elliptical wings. However, during the war, this specific Spitfire actually had clipped wings. While this might offend some of the purists amongst you, I personally am a big fan of them. Without sacrificing too much, the pilot gains a lot out of them, from increased acceleration over to an improved roll rate and better dive performance. The aircraft is powered by the Rolls-Royce Merlin 66. It produces around 1,700 horsepower, has a two-stage supercharger kicking in at about 20,000 feet, that's 5,000 meters. It will allow the Mark 9 to reach about 400 miles an hour, that's 550 kilometers an hour at 20,000 feet, 5,000 meters. And on the different boost settings, of course, and with different fuel used, you might find a little bit of variation there. Now, this Merlin does use the Bendix-Stromberg injection carburetors. And this did away with the issue that the early Merlins, of course, had, where the engine did not handle inverted flying or negative Gs very well. And it replaced also the temporary solutions of the RAE regulator, the official name of what you might know as Miss Schilling's orifice. Now, the Mark 9 had 3 different fuel tanks. The one on top here, sitting flush inside the fuselage, holding 48 gallons, and the lower one holding just below that 37 gallons, that's 85 gallons, roughly 1.5 hours at cruise. with a combat range of about 430 miles, that's 700 kilometers. This is somewhat of a legacy of the fact that the Spitfire was an interceptor rather than an escort fighter. Thus its range was not as important or impressive as some of the other Allied aircraft. Fuel would generally be 100 octane, but you can also have 150 octane fuel. The internal settings has actually quite some advantages and disadvantages. First off, the pilot can actually isolate the different tanks. And if one of them got hit, he could just switch over to the other one and of course also refuel the lower tank with the top tank if need be. The top tank's position meant that installing any kind of protective measure, like a self-sealing fuel tank, was pretty much impossible. It sat flush inside the fuselage. But there was a 3mm aluminum deflector plate that would, deflect incoming bullets mounted on top of it. This problem did not occur with the lower fuel tank, which was able to be self-sealing. A third fuel tank was added to some of the later Spitfires in the back, sometimes split into two halves, but this was only used in special circumstances. Of course, auxiliary and drop tanks were also available to the pilots. Now, talking about armor a little bit, the Mark IX was pretty much the standardized by this point. The very first protection came with the Mark I, but it wasn't armor in the traditional sense. Two bulkheads actually seal off the fuel compartment of the aircraft to prevent the spread of fire and to give the pilot a little bit more time to bail out. By 1939, the first protective measures were being envisioned for the pilots, but since at that time the Hurricanes were actually down in France doing the fighting and the Spitfires were kept back, they had priority. But around about that time, the evacuation of Dunkirk, the Spitfire started to receive armored windscreens protecting the pilot up front, and they also had an armor plating added to the behind the pilot and the seat, roughly 8mm. So the Spitfire's cooling is based on a 70-30 water ethanol glycol mixture. This is housed in a small tank up front here, in front of the engine behind the propeller. The positioning is a little bit precarious since incoming fire can easily rupture this tank, and then also it presents a fire hazard. So a small armor plate was added in front of it, protecting the tank. By the time of the Mark IX, the cooling in the Spitfire was actually automatic, which obviously helped the pilot in flying the aircraft and took a load off his mind. The Mark IX has a rotor 4-bladed hydraulic air screw. Now, on the early Spitfires, the pilot actually had to manually operate the pitch of the air screw, but with the Mark IX, this is of course done automatically as a connection to the throttle. However, he could disconnect this automation and operate it manually, of course. Now, if we swing around then here, under the wing, we've got, of course, the radiators. Now, the outer one here on the right, that would be the oil radiator, and then to the left, that is the engine coolant. This box would be mirrored on the other side, although the oil cooler there would be for the intercooler. Then we have the landing gear here. In the Mark IX, it is steeped at a slightly higher angle in order to counter that weight difference that came in with added weight up front with the engine and so on. And then, of course, we move on to the weapons. We've got a 20mm cannon, Hispano cannon, in the wing on each side, and that is backed up by a 50 cal Browning machine gun. A few notes on the specific aircraft we have right here. As mentioned, it flew with the Canadians during the run-up and execution of D-Day in 1944, 75 years ago. She shares one confirmed kill on a German Bf-109 on the 7th of June, D-Day +1. She was built at Castle Bromwich and flew 60 operational sorties from April to mid-June 44. On her last sortie, she sadly belly landed and was grounded for the remainder of the war and the next 53 years. She was made airworthy once more in the 1990s, while of course joining the Battle of Britain Memorial Flight, who have been taking care of her ever since. Originally, she was painted in the camo of the Canadians with the Asian markings, but since then, she was repainted in the camo of 92 Squadron operating in Tunisia in 1943. One additional change was that the wings were actually extended to the original shape instead of the clipped wing. If you want to know how the RAF conducts modern air operations, check out the following video. I want to thank the Battle of Britain Memorial Flight for letting us film on their premises, and as always, have a great day, good hunting, and see you in the sky.